Hi everyone, my name is Ichi from Moldex3D. So today I will present compression molding simulation for all of you. Okay, this is today's topic. So I will set the 5 topics in this presentation. The first one is the introduction of compression molding. Second one is the compression molding vs injection molding. Third one is the advantage and the disadvantage of the compression molding. Fourth is Moldex3D compression molding module. The final one is the simple case study. The first topic is the introduction of compression molding. As we know, compression molding is the molding process that the operator put the material we call the charge into the mold and then close mold and squeeze the charge into the cavity. And in compression molding, we can use the thermoset material, thermoplastic material, elastomers material, and the natural rubbers. Here we will mention about 3 mold types of compression molding. For the first one is fresh mold type. We can see the right side pictures. Sorry, wait a minute. Let me to use the point to show you. So you can see the picture on the right side. Yeah, after we finish the compression molding, you will see the flash near your part. Yeah, this is because when you use this type mold, you will have a small space. Yeah, so this is the reason why you have a flash. Yeah, and you can see its benefit is less prone to ballisting. Yeah, next one is the positive mold type. Yeah. This one you have to have a accurately measure charge. Yeah, because there is no space, small space in the mold. Yeah, so we can see the pictures. You put the charge in here and compressed. The final one is the semi-positive. It combines the advantage of the 2 different modes. Charge measurement does not need to be as accurate as with positive types modes. Yeah. And it can be an exist that may be allowed to escape during the compression. After we mention the mold types, we will mention about 2 compression molding process. One is the hot, the other one is cold. Yeah. So let us mention about the difference between the 2 compression molding process. In the hot compression molding process, it means the operator need to preheat material before we do the compression molding. Yeah, and we will set the temperature, so the charge should be preheat to the temperature we want. In cold compression molding, we did not preheat the material. We will take place at room temperature. So next one is the process of compression molding. I think in the beginning, I already mentioned about this one, so I will skip it. But in here, we have to focus on the two steps. One is the preheating, the other one is the pressurization. So there are three main phases in compression molding. The first one is the preheating, the second one is the molding, the last one is the cooling. In preheating phase, operator needs to prepare a pre-measured and preheating material. And the charge is heating to the desired temperature. Yeah. So in here, there are three factors you need to consider. One is the pressure, heating, and the temperature. So in the compression molding, I think this is three factors also is important. So in the following slides, you will see this is three factors many times. The next phrase is the molding phrase. It's the mold consisted of an up and a lower half. So during the molding phase, operator needs to place preheating charge into the cavity, into the mold, and close the mold. Then the machine will, the operator need to set the efficient pressure to squeeze the material into the cavity. And you also need to maintain heat and the pressure until the material has cooled. The final stage is cooling phase. After the charge has been molded and cooled, it's time for the cooling phase. Operator need to gradually reduce the temperature of the mold. Yeah, because in this stage, sometimes you will face the warpage issue. Yeah, and the warpage issue is always we face. So here it mentioned about the three main parameters of importance during compression process. The first one is the temperature. The second one is the pressure. The last one is the time. So as I mentioned in previous slides, this is most important in compression molding. Yeah, if you want to see the details, you can contact with our staff and request the documents. You can read it more detail. Yeah, because we have a limitation times, so I will not explain in here. If we go more detail in this is three parameters, we also can separate by important factors we have to consider in compression molding process. The first one is the amount of the plastic. The second one is heating time. Third one is the melting temperature. The fourth is the pressure. The last one is the cooling time. We in the last topic, simple case study, we will use these factors to reduce the warpage. So in the following topics, I will show you again. So in this slide is most important factors that you control in the molding, in compression molding. So this is a stage in compression molding cycle. So I will not mention about this one. If you are interested in, you can contact with our staff to request this document, or you also can search on the website. You will have an idea about this one. Yeah, this is the material used in compression molding. As we mentioned in the beginning, yeah, small set and the small plastic are two primary types of the material used in compression molding. So, okay, next topic is the compression molding vs injection molding. So I will use the one compression table to show you the difference. In this slide, we can see the process, cost, effectiveness, and service quality. Yeah, so in process, heat more cavity is belong to compression molding. Yeah, as we know in the injection molding, the high pressure mold cavity should be used. Yeah, the next one is the cost. Yeah, for compression molding, the cost effective for large and simple parts. Yeah, if you want to make the higher volume, you have to use the injection molding. For the surface quality, both of these molding process are good. So next one is the advantage and the disadvantage of the compression molding. On the advantage side, compression molding offers lower material waste, lower post-processing, higher volume production, quality and strength, lower tooling cost effective, suitable for large part. And for each reason, I will not explain it here. You also can see the PowerPoint to understand more detail. So next one is the disadvantage of the compression molding. The first one is the higher labor cost. The second one is limited material options. Yeah. Post molding cost. Yeah. Limitations: short cycle time, material waste, and limited automation possibility. Yeah, this is the limitation of the compression molding. I will skip this one. Yeah, this one is the problems occurring in compression molding process. You will see a lot of problems in compression molding. In here, I will show you the short, sinkage, and the warpage. Why I have to mention about this is 3 factors. Because for the first one, short, yeah, if you doesn't have enough material, you will have a short problem. And the other two, sinkage and the warpage, yeah, is if you cannot control your like a pressure and the temperature well, you will have this issue. And most of our customer always ask us about the warpage, how to control the warpage. So here, I just emphasize that this is 3 factors for you. This one is the DFN guidelines for compression molding. I will not mention about this one. If you are interested, you can check it. Okay, so next one is the Moldex3D compression molding module. In Moldex3D compression molding module, we support both thermoplastic and thermoset material. It covers feeding, packing, cooling, and the warpage analysis. It supports fiber orientation analysis, support optics and the residual stress analysis with the viscoelasticity, support to read the deformation information from LS Dyna. Yeah. The last one is mode movement. Later, I will mention about this one because this is our new function in 2024 version. This one is the procedure we have in Moldex3D. As I mentioned in previous slide, yeah, the new procedure is our new function in 2024 version. Yeah, and before 2024 version, we only have a simplified procedure. Yeah, the difference between simplified procedure and the new procedure is the cooling channel will move with the mode. Yeah, it means in the simplified procedure, the cooling channel will fix in here. But in the new version, the cooling channel will move with the mode, upper mode. Here is the summary table for you. If today you only have a part without a cooling system, you can use our simplified procedure. If you have a cooling channel, you can use our new procedure. This is the components view from new procedure. Yeah, so you can see the mold plate, cooling channel, part, and the compression zone. This is a limitation of the new procedure. You will see a lot. But the most important is user need to make a matching phase. Yeah, because this is the most important for our new version. And create the mesh maybe have more steps. So I will show you in the following slides. So here I will mention about pre-process of simplified procedure. So this is the flow chart of the simplified procedure. First one, you import data, and then set a compression zone, create a 3D solid model, a solid mesh, apply the charge, set the material and the process condition, run simulation, check the result. So this is the compression zone interface in Moldex3D. In here, you can set the distance, the compression distance, and the direction, and the compression model. This is the applied charge interface. In Moldex3D compression molding process condition interface, we provide 5 main settings. The first one is the compression time. Second one is the maximum compression speed and the compression speed profile, maximum compression force and the compression force profile. So you can see this is the profile setting. For speed, this is the profile setting for compression force. Next one is the pre-process of the new procedure. From the flow chart of the new procedure, you will see it's more steps from simplified procedure. So in the beginning, we have to import a CAD model. This is the same as simplify the procedure. And then you have to attribute more plate and a cooling channel. Next one, create a matching face, a matching mesh. In this step, we create a surface mesh first. Next one, you have to set the moving mold plate and a cooling channel. And set the compression zone. Create a 3D cooling channel solid mesh. Yeah. Manually match the mesh between the cooling channels and the mold plate. Yeah, this is show you how to create the matching phase between cooling channel and the mold plate. Yeah. Finally, you have to create the solid mesh and then apply the charge. Okay, so we already finished how to set the pre-process in Moldex3D. So this is the last topic about simple case study. Here we use the simple case to show you how we use Moldex3D compression molding module to do the simulation. This is the model information you can see in here. And in this case, we use ABS material. And we also use the CAE mode and the default process condition to be the best run. And as I mentioned in the previous slide, my target is reduce total displacement. So how I can change the parameters to reduce the total displacement? We can go back to page 17. Oh, sorry, 18. So in here, as I mentioned, you need enough amount of the plastic material. So in Moldex3D simulation, you need to drop another cat for this one. The second one is preheating time. It means you have to preheat your charge. Yeah, so you have to control the preheating time. So in simulation, we did not use this one. So I will use the melting temperature and the pressure and the cooling time to be the revised process condition. Okay, let us go back to the simple case. Here you can see the revised process condition 1. I changed the cooling time from 20 seconds to 40 seconds. Here, 20 seconds to 40. The second revised condition is I change melt temperature from 230 degree to 250 degree. The last one, I changed the compression force here from 3,140 to 1,500. Yeah. In Moldex3D compression molding result, you can check the melt from time. In the melt from time, you can see the feeding pattern. You also can check the potential in completed feeding. Also can see the wet line, air track, and the balance. This is 4 runs melt from time animation. So in this slide, you can see the melt from time animation is the same. It's not different. It's not different. In Moldex3D result, we also provide the air track and the wet line. Because in this is 4 runs, the flow pattern is the same. So the air track and the wet line result is the same. The next one is the pressure. Yeah. In the pressure result, we can check the flow balance, overpacking, or pressure drop. This is the compression table, compression table. So here we see the melt temperature. We change to 250 degrees. The result is the pressure result is less than another 3 runs. This is the temperature you can see in Moldex3D. This is the compression table for 4 runs. We also can see the melt temperature 250 degrees. The temperature result is higher than another 3. Next one, we will review the balance sinkage. Non-uniform balance sinkage will lead to warpage and the distortion of the molded part. Yeah, so this is the result compression. In here, we also can see if you change the higher melt temperature, the balance sinkage result is higher than another 3. This is sigma indicator. Sigma indicator is also an index to evaluate the packing effect. So let us to check the result. You also can see if you change the melt temperature higher than the original one, the sigma indicator also higher than another 3. Next one is the sigma displacement. It's been higher value means serious sigma defect. And this is the compression table. So again, you also can see the higher melt temperature. The result is higher than another 3 runs. In Moldex3D, we also provide a fiber orientation. So you can check this result to understand the fiber orientation situation in your part. Yeah. We also provide a particle tracer result for you to see how the melt, how the plastic go into the cavity. Yeah, because this is 4 runs. The melt from time is similar, so I did not show another 3 runs result. I just used the 1 result to show you. In Moldex3D result, you also can see the damping force. So this is the compressor table. Yeah. Here you also can see if we change the higher melt temperature, the damping force is lower than another threes. Last one is our target because we want to reduce the warpage. In Moldex3D, we provide the total displacement, X displacement, Y displacement, and the Z displacement. So this is the total displacement compression table. Yeah, so in this table, we will see the cooling time. We extend the cooling time, the warpage total displacement result is the best. So we use the table to put all of the result in this table. Yeah. From this table, we can understand changing cooling time and the melt temperature will have a significant improvement in total displacement. But in this case, I think we change the cooling time is the best one. Okay, before we finish the presentation, I will show you the difference between simplified procedure and the new procedure. So this is the melt front time animation in new procedure. So you can see the up mode will move to close the lower mode. So the cooling channel and the up cavity will close to the lower mode. Here is the cooling temperature result in new procedure. So in here, you will see the cooling temperature will have a different in the process. So this slide is to show you the comparison between simplified procedure and the new procedure. Yeah. So from this, the pictures, we will understand the cooling temperature result is more better in new procedure because the cooling channel will move with up mode. This is also a cooling temperature result. We use the clip function to show you inside the mode situation. So, okay, this is the summary about Moldex3D 2024. Yeah. So if you have a cooling channel in your design, we suggest you to use our new procedure to do the compression molding simulation because you will get more correct cooling result. So last one is the reference. Because I make this PowerPoint, I use some like a website information, so I have to put the reference in here.